Hello everyone, my name is Hassam, and in this video I'm going to go over the takeoff distance, how to calculate your takeoff distance. And this example is based on this packet that we have. It's based on the takeoff distance charts for a Cessna 172. And our maximum takeoff weight is 2,300 pounds. Very good. So we go directly to that section, number 3 right here. Very good. So takeoff distance. How are we going to calculate the takeoff distance? So first of all, we're going to look at this chart, and I'm going to explain the chart a little bit, and we're going to go over finding all our numbers. So there is an easy way to look at this chart. This chart is basically based on your weight, your specific weight. Right here is 2,300 pounds, and as you can see, this chart is based on the pressure altitude. So we calculated the pressure altitude for today, and if you are not sure how to calculate the pressure altitude, I just suggest you to watch our video on calculating the pressure altitude on its on topic. So we are not going to go over finding pressure altitude in this video. However, today's pressure altitude is 500 feet, so we are going to calculate the numbers between whatever number is down for 1,000 feet and also sea level. So it's going to be between right here and right here is going to be 500 feet. Today's METAR is shown above right here. So temperature is 19 degrees Celsius, and as we mentioned, pressure altitude is 500 feet. So as we can see here, we have 5 different columns for the temperature. So we know that the temperature affects our performance as we get higher and higher in temperature. As the air gets warmer, we need more distance to become airborne and rotate and become airborne. So if it's cold, we need just if it's cold weather, just 0 degrees Celsius, we just need 720 feet of runway to take off at sea level, versus 1,700 feet, almost 3 times bigger, when it's 40 degrees Celsius. It's a very hot day, we need more runway. So basically, in real life, we're gonna calculate the maximum or the worst case scenario for our temperature. If this is today is 25 degrees, and I'm taking off from John Wayne and our pressure altitude is 500, I'm gonna go look at right here at 1,000 because it's the worst case scenario. I'm gonna go over here. I know that, okay, for ground roll I need 900 feet, and for total to clear 50-foot obstacle I just need 30 feet of runway. So but for purpose of this video, I'm gonna show you to interpolate between the numbers and find the exact value for this example right here. So I'm gonna go over one more thing before we continue. We just need to know that what is the difference between the ground roll and the total to clear. If you look at this diagram right here, I'm going to show you right here. It's ground roll is this distance that we need to power up and then rotate and become airborne. But however, if you have an obstacle at the end of the runway, not only we have used this much of runway, we have to rotate and become airborne and basically be at our Vx s speed, which is best angle of climb, and clear that obstacle as soon as possible, and then we can go back to our Vy, which is best rate of speed of climb, so we can safely continue our flight. So technically we have used this much of runway, so that's why always the total to clear 50-foot obstacle is much higher number than the ground roll. So back to here, our example, today's temperature is 19 degrees Celsius, so it's not 10, it's not 20, but 19. So I divided this degrees, the difference between the 10 and 20, in 10 increments, so each increment is 1 degree. So this is 11, 12, 13, and so forth. So we are looking about right here, so about this much of distance is gone from 10 degrees to 20 degrees. So we see that for 10 degrees at 10 degrees Celsius, for a ground roll we need 700 feet, versus if the weather gets hotter and 20 degrees, we have 835 degrees at sea level. So we have to find 500 feet first to find the numbers between these two. We're gonna use this method. So I'm gonna take the bigger number, take the difference between the bigger number and the smaller number, and divide it by 2, and it gives me the average. So basically the average between these two numbers is 812, and between these two numbers it's 1458, and between these two numbers right there and between these two numbers it's right here. So we can find right now we can find the 500 feet pressure altitude. This is the 500 feet pressure altitude at 10 degrees, and this is the 500 feet for 20 degrees. So now we have to interpolate between these two numbers, 812 and 875, and find the exact value for 19 degree, because these are all the numbers for 10 degrees. This is the ground roll, and this is the total to clear 50-foot obstacle. Also, this is these two columns are for 20 degrees. So now we're going to find for 19 degrees. How we can find it? It's a very easy way to do it. So if you can look at a percentage like a solution type of thing. So it's if you consider the whole change from 10 degree to 20 degree as 100% change, so this much change has been made. So it's 90%, or you can say we are 10% short of the values for 20 degrees. So in other words, if we have this number right here, we have 812 and we have 875. We got it from interpolation between these two numbers and these two numbers. They're all together. Like, so you have to look at ground roll and total to clear 50-foot obstacle together. You can see here that we take 875 and we take the difference. It's only 63 difference between these two. So we just need 10% that of that difference off. So because of here we just need 10% off. So if we take 6.3 off of 10% of 63 is 6.3. So we take 6.3 off, we get 57, and we add that to our little number, which is 812. We find 869 for the ground roll, and we do the same thing for here. So we have this number. We calculated that 1564 is here, and then 1458 is here. We take the difference is 106, and 10% of that, we take 10% off, it gets 96, and we add it to the little number, and the total to clear 50-foot obstacle is 1553 feet. Very good. And now we have to pay attention to note 3, which says decrease distances 10% for each 9 knots of headwind. So we're going to rephrase that sentence in another word to make it easier to understand. So if each 9 knots of headwind we need to decrease 10%, it means that each 1 knots of headwind, it's going to be 1.1%. So if we have 18 knots of headwind, we multiply that by 1.1 and we get 20% decrease. So we decrease our ground roll by 20%, we get 717. We do the same thing for our total to clear 50-foot obstacle. We decrease that by 20% and we get to 1243 feet. So now we need to do the final step. The final step says that we have to calculate the slope of the runway and do the effects of upslope and downslope runway. So let's look at our runway one more time here. We have chosen runway 20 left for our takeoff purpose. So we have here about 0.4 degree upslope on that runway. We know as a rule of thumb that each 1% is 10. Each 1 degree of its upslope is 10% increase. So one more time, each 1 degree is 1%. Each 1 degree of slope is 1%. So 0.4 degree is 4%, right? So let's do that together. So we know that here we have 717. We add 4% to that to get 746. So now we know that, okay, for this upper slope we need, actually we need to be airborne, we need 746 feet, right? So what is the difference between 746 feet and 717? If we use our calculator here, so 746 plus, actually 746 minus 717 is 29 feet. So we need to add this 29 feet to our total to get the final value for our total to clear 50-foot obstacle. Thank you so much for watching, and please don't forget to leave your comments below so we can make better videos for you in the future. See you later.